Hello, welcome back once again. Please, if you have not subscribed to our channel, please subscribe to this channel and share our videos. Thank you. Now we have a very nice infinite sum here. Sum as k goes from 1 to infinity, the n minus 1th root of k raised to power 1 minus n plus k plus 1 raised to power 1 minus n all over k raised to power n minus 1 plus k plus 1 raised to power n minus 1. I believe that this looks a little bit scaring, right? But let us see how we are going to solve this problem, right? So the first thing to do here is to try to simplify this expression right over here, right? So I'm going to start as follows. Here we let m is equal to the numerator right over here, k raised to the power of 1 minus n plus k plus 1 raised to the power 1 minus n. So simplifying this, so here we have k raised to the power of 1 over k raised to the power of n, right? Since we have this law, a raised to the power of b minus c is the same as a raised to the power of b over a raised to the power of c, right? Because we have common basis here, so we can subtract the power since we have a division, right? So this is the division law. So for more clarification, here we have these laws, right? A raised to the power b times a raised to the power c is equal to a raised to the power b plus c, right? Because of this multiplication sign, we add the powers, right? Since we have equal basis. And right over here we have equal basis, we have a division sign here. So we're going to subtract the powers. So that's why we have here a raised to the power of b minus c. Right over here we have plus. Here we have k plus 1 raised to the power of this 1 here. So which is the same as k plus 1, then all over k plus 1 raised to the power of n, right? So we can actually simplify more, right? So m is equal to, here we have the common denominator here as k raised to the power of n times k plus 1 raised to the power of n. This divided by this, we are left with k plus 1 raised to the power n times this. So we have k times k plus 1 raised to the power of n, then plus. Right over here, if we divide this by this, we are left with k raised to the power n times k plus 1. So k raised to the power n times k plus 1, right? Okay, now here we have to let n equals the denominator here, k raised to the power of n minus 1 plus k plus 1 raised to the power n minus 1. So this is equal to using this rule. So here we have k raised to the power of n over k, right? Then plus k plus 1 raised to the power of n over k plus 1. So the common denominator here is k times k plus 1. So if this divided by this, we're left with k plus 1 times k raised to the power of n. Then plus, right over here, this divided by this, we're left with just k times k plus 1 raised to the power of n. Okay, now since we have simplified this, so we need to divide m by n as required. So here we have m all over n is equal to, right over here, so here we have k open bracket k plus 1 raised to the power of n plus k raised to the power of n open bracket k plus 1, or divide by k raised to the power of n open bracket k plus 1 raised to the power of n. So instead of to write this division in this form, so I will try to write it like this, then divided by n, k raised to the power of n open bracket k plus 1 plus k open bracket k plus 1 raised to the power of n all over k open bracket k plus 1. So now this I'm going to rewrite as follows: k open bracket k plus 1 raised to the power of n plus k raised to the power of n open bracket k plus 1 all over k raised to the power of n open bracket k plus 1 raised to the power of n. Then if I should change these two times, I'm going to take the reciprocal of this fraction here, right? So we are going to have just k uppercase k plus 1 all over k raised to the power of n uppercase k plus 1 plus k uppercase k plus 1 raised to the power of n, right? So look at this here. This and this are exactly equal. So we're going to cancel out this and cancel out this, right? So we have here m over n is just equal to k uppercase k plus 1 all over k raised to the power of n uppercase k plus 1 raised to the power of n, right? So now we're going to rewrite this as follows. So this k here, that k up there, we can rewrite k as 1 over k raised to the power of negative 1, right? So k can be written in this form. That is, k is equal to 1 all over k raised to the power of negative 1. And right over here, k plus 1 is the same as 1 all over k plus 1 raised to the power of negative 1. So we are going to multiply. Okay, let us do that first. So right over here we have 1 over k raised to the power of n, k plus 1 raised to the power of n, times, so this numerator, writing it as follows, k raised to the power of negative 1 times k plus 1 raised to the power of negative 1. So, you know, k raised to the power of n times k raised to the power of negative 1, we add the powers, right? So we're going to have 1 over k raised to the power of n minus 1, then times k plus 1 raised to the power of n minus 1. Okay, so we're going to take n minus 1th root, right? So as required, so we have here n minus 1th root of m over n is going to be what? N minus 1th root of what? 1 over k raised to the power n minus 1 times k plus 1 raised to the power n minus 1. So we know this property. When we have something like this, the 8th root of 1 over n raised to the power k, so this is same as 1 over n raised to the power k over a, right? So we're going to make use of this property right over here. So we're going to have 1 all over k raised to the power n minus 1 over n minus 1 times k plus 1 raised to the power n minus 1 over n minus 1. So this simplifies to just 1 over k, open bracket, k plus 1, because this cancel out. Okay, good. Now we're going to evaluate this infinite series right now. So we have this sum, k goes from 1 to infinity of this 1 over k open bracket k plus 1. So we're going to find the value of this infinite series. So I'm going to decompose this into sums of partial fraction, and that will be exactly equal to k goes from 1 to infinity, then 1 over k minus 1 over k plus 1. If you decompose this into sums of partial fraction, so this is what we have. And right over here, I'm going to be inputting the values of k as it goes from 1 to infinity, right? So the first bracket, when k is equal to 1, we have 1 over 1 minus 1 over 1 plus 1, 2. Then plus the second bracket, when k is equal to 2, we have 1 over 2 minus 1 over 3, plus when k is equal to 3, we have 1 over 3 minus 1 over 4, close bracket, plus, and so on, right? So we can see that this is just a telescoping series, right? Since k goes from 1 to infinity, so only the first term survives, right? So let us try to remove the brackets and make our cancellations. So this is equal to 1 over 1 minus 1 over 2 plus 1 over 2 minus 1 over 3 plus 1 over 3 minus, and so on. And this is equal to, you know, negative 1 over 2 plus 1 over 2 is gone. Negative 1 over 3 plus 1 over 3 is gone. This cancellation continues forever. And here we just have 1 over 1. And this is just equal to 1. And this is our final answer. Please, if you find our video very interesting, please do not forget to do what? To support our channel by subscribing. Thank you.